Okay, so here we go. The recording is automatically done. I've got to get used to this since usually I've been working with Adobe Connect a lot. But now I'm sharing my screen here, and what we'll talk about today is it brought very shallow introduction of what Java Enterprise is, why it is of relevance to you as an becoming or already starting developer, starting your third year of the bachelor's program, Programmiertechnik. Then we'll talk about the course, the objectives, the structure, how the course is set up, and some words about pointers to literature, some of it that is mandatory, some of it that is just a recommendation, and the agenda, where you get an overview of the different deadlines, and recommend. Some of them are mandatory and some of them are just recommended deadlines, and this will be outlined here and also in the overview material that you can download from the GitHub and from the Bitbucket Git repository. In general, just for you to know, for your note, all the information should be available. I just want to make this a bit more of a hello experience where we all get to know each other and have a little kickoff where we can even have a chat if you're interested in that. So starting out with the big topic of enterprise software. What is actually enterprise software? And Oracle itself, who owns the term in a way, or at least it owned the term before Sun took over. Java Platform Enterprise Edition, Java EE7, is the industry standard for enterprise Java computing, they say. And if you get this spinning around in your head for a little while, then you probably realize that this is not saying us too much. Explaining a term by a term, it's not giving any value. Enterprise, substitute by enterprise, and Java computing. Yeah, okay, we do some computing, meaning we have programs that are running on a computer. So I just want to warn you that within this field of so-called enterprise software, there is a lot of terms that might seem very unfamiliar for you. But if you go to the bottom of what they technically mean, oftentimes they just describe something that you already know. But importance with enterprise software is that we get a vocabulary to express these things in a meaningful way, and that we understand others that talk about these terms. So there is a big buzzword alarm. Many things are redundantly explained, and I try to give a bit more of a deeper, clearer view of what these terms really mean under the hood. So a more simple and better explanation, as I find it at least, is this one found somewhere on Wikipedia. It's that enterprise software used in organizations such as businesses or governments. And well, businesses or governments are here also just something that we can personally easily relate to, but the term enterprise, at least in recent years, has stretched further to ongoing starting businesses or governmental institutions like universities and so. But to just give some terms of bodies or entities that use enterprise software shouldn't be enough. We can actually dig deeper and look into the details of what actually makes an application enterprise. And there are some metrics that we can measure the enterpriseness, if you so will, of an application. And that is, are we dealing really with a lot of data? Are we dealing with a lot of users? Usually we talk about concurrent users using the product or the service at the same time. We're having a substantial amount of logic. So we're talking about many modules, probably that also use external third-party modules that interact with one another. And we're looking into potentially very complex system interactions. we have a domain model that is complex, and usually we talk about a system that is under heavy and constant load. And these all are definitions that are that can be found in the course book by Martin Fowler, which I also get to a bit later. Traditionally, we could we only had basically one choice of how we would develop our software in a company if we were to to create some software. We would get some CDs or tapes or whatever in the store, and we take it home with us, and we do the development home. We install our development environment or languages, etc., through drives, and we have all that back home. Now, these days, due to the availability of data, basically, and data sharing of different kind through the internet, we always have the alternative to have our enterprise software being placed in the cloud. So we can make strategic choices towards either using one or the other, with certain advantages and disadvantages. The cloud gives us a high level of accessibility. We can be spread out teams that work together on projects easily without having with crossing the location boundary easily. Whereas in-house, at least seemingly, we have a higher security because we might have our systems not being even connected to the internet, so that it's not possible for others to get in, at least not through the network. And another advantage of the cloud services is that you have a higher level of transparency. Everything could at least be reachable through the internet, and that also means that we can more easily share progress, more easily share our live information of what's going on. And whereas in the in-house situation, we have a higher level of control of what's going on. If something's hanging, say in the Google or in the Amazon cloud, and we don't really know what's going on there, we have great tools these days to monitor these things, but we don't really have control of what's happening there. We still rely on the cloud platform providers. So generally, in-house solutions then come with an overhead, where you have to consider the complexity and responsibility of hosting things yourself. What if things break? You have to take care of maintenance, and you have certain costs to consider when it comes to hardware. But that is probably why many companies now always, with whatever decision they're making according to services and software, they can choose either or they don't have to go with a strategy that is full-fledged in-house or full-fledged cloud. They can go with a hybrid. That wouldn't be a problem at all. So that is the common way, that you always make your decisions depending on the current problem that you're trying to solve. Whereas maybe some of the security, more sensitive systems you would like to have in-house, you could have other systems that are accessible, that your customers should be using from many places, that's easily load balanced and easily managed and backed up, etc. in the cloud. When we develop enterprises through software, usually what we do when we create the modules is that we build the foundation, the internals of the software, and traditionally this has been one of the biggest things, right? When I started developing and starting working at IBM some 13 years ago, I would be faced with a problem and a new customer, and the first thing I would do is drawing a relational database model. And so that together with the different services that we want to supply to the user has always been traditionally a very important thing. Now, this has been moved a little bit to an understanding where we have realized that what is actually important, and what Uncle Bob is also mentioning oftentimes, is that the data itself, or the data model itself, and the data source is just a detail of our system. The most important thing is the domain logic, and that's building the foundation. What are the services that we want to offer? What is the real meat and what we're trying to offer? And usually we're not in the fancy situation where we can decide the entire domain logic or the data model by ourselves. Usually, we are prepared with an existing system, and that let it be a relational database system, for instance, which is still, when it comes to those that we are developing on, and that you are likely to be developing on when you started a company, the most spread model. You will have relational tables that are poorly documented, that have columns that you might not really understand, many null values, things that really are untested. So it's hard for you to get going, but that's the reality that we live with. So in enterprise development, we try to have tools that help us dealing with these things more easily. And building up on that, we create, given certain user requests, we create extensions on our services. That's what we are paid for. If we now work in consultancy, or if we do that in-house, it doesn't really matter. But that's the common case, and we're trying to identify reusable components, and we're trying to separate modules in a meaningful way so that we can actually substitute them easily at a later point in time. We can more easily identify problems, we can make them more testable, etc. And oftentimes when, say, a company is acquired by another company, we have to somehow allow the data that these two have to have that exchanged, or to have that backed up in a common pattern, etc. So we're building bridges between these different systems, integrating them. The last aspect that's important for enterprise development is the efficiency to not only have a system that is able to take care of all these users concurrently at the same times with high loads, video content, multimedia, you name it, but also do that in a way so that the customer is actually, or the user, depending on what that is for a service, is actually pleased with the experience. So the system should be scalable, and it should be performant. And especially this last part, the improvement of efficiency, requires a lot of skills that are related to experimental design, and making sure to really set up the environment, the test environment, and the development and the production environment in a very similar way, in order to make sure that things don't break. We will not cover that part to a large extent. So this course will mainly be dealing with those other parts. We will only be sniffing a bit on the improvement of efficiency. These days, there's a lot of talk about microservices, talk about containerization, we talk about microservices, cutting the huge formerly software applications that were usually shipped as one, with a lot of services included in this one huge application, with a single version counter, into smaller reusable components. And these days we talk about microservices. There's been a run some 10 years ago or 15 years ago about service-oriented architectures. And some people claim that microservices is service-oriented architectures done right. I don't know if that's true, but at least now we have the tools to make this transition from a monolithic application to many small modularized applications that actually run independently much easier, due to containerization and the tools that we have for containerization, and these platforms like Kubernetes and Docker Swarm, etc. So we even in the Java and enterprise development world start to realize and understand that we have to adjust to the changes, and we try to create small services that are self-dependent, and that even can run without other related services that we depend on to be up and running. One example is, if you have a database and you depend on the database connectivity, do you have to have that connectivity available when the server is starting? Maybe not. Maybe you only need that connectivity running when the first user is actually requesting that information. And this requires some smart coding, or Now these days, actually, this is partly taken over by the smart tools that we will take up. The servers are getting smarter and helping us with these kind of things, because we're talking so much about microservices in the outer world. So why a course like this? Why do you have to learn about Java Enterprise? There is a demand in the industry for enterprise knowledge, which is due to the high use of specifications used in Java Enterprise. Java Enterprise is, as I will go into detail a bit later, a superset of standards. And these standards are used in many large companies, state-based or governmental institutions, or even private, that have CRM systems, or that have larger services like Netflix are basing their systems on Java. And there is the knowledge that we're learning through the Java courses that we are having at the university, but then there is the knowledge that is required to create these server-based systems, and there is quite a gap between them. And that's the reason why this course came about. We want to make sure that we have a sound theoretical foundation, and still have this grounded in some practice and vocabulary that we can use. So once you get started working in the industry, you're not surprised when you hear about patterns like the facade pattern or the layering or gateways. You can immediately get started, and you know some of the standards at least that deal with persistence and transactional management, etc. So you can be productive more easily. And so after the course, you should be able to quickly be productive. You're probably not an expert in Java EE. There is just many things that we don't cover explicitly in the course, and but the basics that allow you to elaborate and further learn the concepts that we don't cover, you will learn in this course. So it will be rather easy for you to learn new techniques and new, say, for instance, libraries to create your user interface according to maybe more modern frameworks. You will have a vocabulary, which I already mentioned, which is one of the important things, and you will understand the concepts of enterprise development, what it means to have these server applications that are running constantly in the background, and what they have to make sure in terms of security and transactional management, etc. And this also applies to all other platforms, being it Python, or being it .NET, or any other Ruby on Rails, you name it, Node.js. So we try to cover general knowledge here. So from a very general perspective, it can make sense to structure systems, and this is probably what you already have been learning, to structure the systems in some kind of architectural terms, and try to see a structure that is that can be implemented with meaningful interfaces. Having this in mind can help us. And we usually talk about architectures now when we talk about structure of software systems. And one of the most basic ways of differentiating different important layers of the system is to have in the heart of everything the domain logic. As I mentioned, as Uncle Bob says, that's the core. That's everything. Everything else is just details. So given that, we have interfaces from our core logic to, on the one hand side, the way we store the data source. How do we persist our data? How do we make sure that the data is consistent and that it gives some certain guarantees of quality of service and transactional boundaries, and so that we can use it concurrently, for instance, and that not everybody can access it, etc. So that's the data source. And on top of it, we have the user interface. We can have multiple user interfaces, of course. That's just a way to modularize the most simple so-called 3-tier view of things. We have domain logic, on top of that the user interfaces, and below that the data sources. This says nothing about how we structure them internally, or how we actually deploy them. If we have systems, implementations that are co-locating the applications on each and every node with all 3 parts, or if we're actually doing some more horizontal scaling, where when we have certain nodes that are taking care of the data sources, certain nodes that are taking care of the domain logic, etc. That all depends on the problem we're actually facing. And since the domain logic is the heart of everything, and the management of these services that we're offering can be crucial to an efficiency in the whole enterprise, because we want to make sure that things are reusable, and we want to make sure that they're easy to use and interfaces are clean. There is a whole area of development just related to how these services interrelate to one another. And this is mostly for you to know that from the what's it called, the leadership perspective. There is the ambition to be able to, on a more or less a tablet, be able to move the services to one another and have the dependencies set up, etc. And this is called the business process management, orchestrating these services. And that is nothing that we will be looking into in detail, but it's an interesting interface that you will probably meet, and that you will probably hear the term business process management once you start working at a big organization. Now more details about the course per se. The collaboration is being done by a forum on Riva. And as I understood, most of you should be familiar with Riva, because there is a student forum that has been up now for some years, I think, and all year, all different, the different years that pass, the new students are being put in there, or you can apply to get inside, and you have discussions about the program, etc., which is internal to the students, and that's great. So now we will try to use the same technique, so you should be familiar with that. And you see the room up here to the left. You should have received an invite already. If you didn't have, then you should contact me. So send me a mail and ask me why not, because there could be something with the registration. If you're late registered, then there might be some reasons for why I didn't have you on the list, etc. So just send me a mail, and I'll add you to the course in the course forum. So all the communication will be taking place there, nothing in Moodle. All the important announcements will be made there in the announcements forum. There is an announcements forum there. And you are free to share links to your source code and chat and collaborate with each other however you feel. We're using that forum for communication. If you have any general questions that are related to an assignment, etc., put them there. We try to keep email contact, the one person to one person contact, to a minimum, and reduce that to basically personal issues, matters of some kind. And this course takes a bit of a different take than you're probably used to, in that assignments are not to be handed in through a hand-in box or something. So the assignments, at least the ones that you are developing throughout the course, they are just for your own knowledge acquisition, for getting to know about the technology, for collaborating together to solve those assignments, and also to, of course, ask me or ask anyone on the forum then about certain issues that come up. But you don't have to submit them. However, you can share them through Bitbucket. So I've created a team there, and that's probably the next slide here. Yes, where you can put in a workspace project, which you will find there, because you're supposed to follow the instructions on the Moodle course board, and there you will find that you should send me your credentials, Bitbucket credentials, once you have signed up there. And then you will be put into this collaboration team. It's called a team on Bitbucket, allowing you to share your code, to see others' code, and giving feedback to each other about the code, and forking the code as at free will. Make sure to use your Miyun mail address while signing up, because then you will have unlimited academic access, which will allow you to create as many repositories as you feel like, with as many users and co-collaborators as you wish. That's basically it. I think most of you have already been using Bitbucket, but if you haven't, it's very similar to GitHub or other places. One advantage with building teams in Bitbucket is that whatever you put there, it can only be seen by those in the team. So you're not making anything public to everybody. We together can access it and work on solutions there in the scope of the course. And if you need some more references on Git, you can take a look at this book, for instance. Of course, we can discuss things on the course board on Riva, but be reminded that a pre-requirement for the course is the methods and tools course that we are having in the Programmiertechnik program. So it is a requirement for you to know about version control using Git. And yes, here is an example of what you could do if you would like to have a more social experience. And in my opinion, one of the most giving experiences when it comes to software development and education is that you actually peer program. You sit together and work on something together. One is typing and the other one is explaining what's to be done, and you have a constant deep discussion about a dialogue about what's going on. And one way to do this on distance is the Saros project. It's a tool for Eclipse. You can install that in Eclipse. Just as an example. Then I would like to say that I personally work a lot with Eclipse. I've changed the course this year so that it's more or less IDE agnostic. So you can use any IDE you wish. It's up to you. The only thing is that you should, we're using Maven for sharing the code and repository handling and dependency handling. The only thing is that I can't help you with details about other environments, development environments. So if you want to get feedback about and comments about the development environments, then, well, use Eclipse, because then I can help you. Otherwise, you're kind of on your own there. Now, I could walk you through the different learning objects, but I think I keep that short, because this will also be part in the next part, in the second part of this lecture. But just for you to know, there will be 6 learning objects. The first one is on persistence, basically how we store information, how we store our data using a standard specification, which is called JPA. The second one is on services and service architectures, what there's been for different architectures, like the SOA architecture type and REST, and how they're different, and the proprietary type RMI, which is a basis of what we'll later learn our application servers are using in order to distribute workload. So these are different service architectures that we will look into. Then in learning object 3, we talk about web development. How do we actually create content that is not only static but also dynamic, and how do we do that using the Java EE standard of servlets, JSP, facelets, and JSF. The fourth learning object is Java Enterprise Development, where we look deeper into how we can actually take advantage of the enterprise Java Bean standard. That means the transactional management, the security management, the logging, all of these aspects. These have to be developed for all applications again and again and again. And Java Enterprise gives us a standard, the EJB standard, that allows us to reuse these kind of services in a so-called container. And creating these our services in a container requires a different thinking and a different mindset than building them in some Java Standard Edition code, for instance. So this is something that we will dive deeper in the Learning Object 4. And then Learning Object 5, we talk about transactional management. How do we make sure that our data is correctly stored and it can still be used concurrently by many users at the same time? All the aspects related to that will be covered in the Learning Object 5. And we'll in the assignment that is part of Learning Object 5, we will integrate a third-party service namely Google Calendar, in order to see what kind of transactional problems can come up when we integrate a third-party service in an application that has to be reliable. And Learning Object 6 is about security and threat protection. What are the biggest risks today? How do we in Java Enterprise can protect us in order to not fall victim to these risks? And there will be an assignment also later announced. So about the course structure, there is a lab moment. I mentioned that the assignments are all just nothing is compulsory. You just do your assignments in your pace. There are some recommended deadlines, but it's up to you. But be prepared for two things that have to be done. One is the lab, the individual project that has to be developed and submitted. And all information about that can be found in the overview document of the course. But just a brief overview here. Each of you will choose one of the projects that are listed in the projects PDF that you can find in the material repository on Bitbucket in our team. You can find it there. It's not many repositories there yet, so you can easily find it there. And it's also linked to in the overview slides. Choose one of the projects and book it by writing down your claim in the Riva forum, for individual projects. And once you get it confirmed by me, then you know that's your project and that's what you're going to work with. And you shouldn't do this later than the 24th of September, because this task is at the same time the task that shows me that you're actively working on the course. I don't know if you probably know about the 3 weeks rule or something that ensures that you're an active student. So make sure to hit this deadline. Yeah, so and then you can read the instructions. It's basically about solving it, having some kind of solution. There is not one right solution. There are many ways of solving the problem, but also to demonstrate it, that you're creating a screencast that is a maximum of 10 minutes, where you actually from scratch show how you develop your solution. And yes, the third part of this lab, there's the 3 total parts, is that you should do some peer review, where you look into others' co-learners' projects and you give them some kind of grading of how clear is the presentation, how complete is the work, how is the code quality. This in order for you to get better at evaluating these things, getting a feel for how you evaluate things on an objective basis, and at the same time help others to improve their presentation skills and their coding skills. So we're here to learn, we're here to help each other. Of course, we try to be kind to one another, but have in mind to be constructive and try to say what you think was good and what you would like to see more, and emphasize also on what you would like to see less of. Then you will be good in that respect. Literature. There is one book which is the course book. I put even a link on a place where you can download it. So you can download it just and have it as an ebook or PDF. My recommendation is that you buy it anyway, because it's a great book. It's an old book from 2002, but the patterns still remain as current as possible. Almost all of them, at least the ones that we talk about. And that is covering the more theoretical part of the course, whereas the Java EE7 tutorial is covering the more practical part of the course. And then there is a number of highly recommended books that I generally recommend. And one of the great books for software developers is Clean Code. It's Robert C. Martin, who I call Uncle Bob. Has a beautiful way of simply explaining how you can write code so that it's easy to maintain, it's easy to test, it's easy to understand for somebody, even for yourself, looking at it some days later or weeks later, even months. Then there are books about microservices, which I really can recommend. None of those books are a requirement here, but I gave 2 of these books stars because they're more highly related to Java Enterprise development, and they're quite new. The one is on the developer handbook, which gives you a hands-on examples of things, and the continuous enterprise development in Java book, which has a more test-driven approach to things, which is talking about a test environment for testing these enterprise services, because that's also putting some extra difficulties on you as a tester, because usually your services depend on other services to function. How do you mock them out in a good way in a server environment, etc.? This is taken up in the book. We will only touch this slightly. But you don't need these books. There are loads of examples on the internet, and I'm pointing to those that are required for you to understand the basics. The Java EE specification is, basically, the Java EE7 is the current version. Rumors tell that to this year there should be an 8th version coming out, which then should be supporting Java 8. But we don't know that because that's been delayed for some time. I think, 2013 Java EE7 came out. So it's been here for a long time. And what it means is it's a specification that contains a number of specifications. So whenever we talk about Java EE7, we talk about these specifications and their version number. So for instance, we have one that's called JPA 2.1 that is on persistence, how we store data in databases. There are newer versions of JPA that are discussed and that will be part of Java EE8, but these features we can't use in a Java EE7 environment. So for instance, if you download a Java EE7 compliant server, you know that you can rely on all the features that should be available on all these specifications, but not those that might be added later. So JSP 2.3, for instance, if there is something in 2.4, we can't use it in a Java EE7 server. And yes, you could look at these specification data sheets, but they're very thick, they're very complex, and I think at this point they don't give you too much value. Only if you want to dig deep into very specific features and definitions, you might want to use the specification text. Otherwise, the formerly mentioned tutorial, the Java EE7 tutorial that is linked to on the net, will be absolutely sufficient to work with in this course. Yes, we're using JDK 8. We can use Java 8 in Java Enterprise 7 as possible. And these are somewhat independent versions, the Enterprise and the JDK versions. And this is, just as a note, I mean, this is an advanced level course. This might be the first advanced level course that you're taking. It will take time to get used to some certain libraries that we're using, third level libraries. There won't be explanations of everything. If you have questions, put them on the forum. We can talk about these things. You can help each other. But not everything is covered in detail. But there will be definitely links for you to get help with things. So just as a reminder that some digging has to be done for some of the assignments to be working. And yeah, there is not one single right way to solve the assignment. So usually what in the best of cases, I would want you to get out of any discussion about Java Enterprise development with a debate about pros and cons of the different solutions. And that would be the best case. That would also prepare you best for the examination. Lecture dates today and 6 more. And these are spread over the whole term, because now this course for the first time goes in a 25% workload. And I made it so that all the sessions are at the same time. And it's not mandatory to be here. You have the chance to chat with me, to talk about these things live here, but otherwise it's up to you. Usually we say roughly 1 hour, 45 minutes at max. Yeah, and the last session is 4th of December, so you know you will have some time there to study and to finish your labs in the beginning of January, which you see here. So here's the recommended pace for you to solve the assignments. And as you see, there are 3 green lines here. Those are the ones that are short deadlines, so you have to really hand in at that time. Otherwise, it's too late. Otherwise, the others are just recommendations. So when you get started with a certain assignment, say you take a look at Learning Object 1 and Assignment 1, here, Object Relational Mapping, I would give you now some 3.5 weeks or so to solve that. I think that's a reasonable time, given the 25% workload. And then I try to structure it in a way so that it's more or less fairly in relation to how difficult the task is. You get time related to that. And then you will see here on the, which obviously is not only a recommended deadline, but it's a requirement for you if you want to pass the course at the end of the term. Then the 18th and 19th of January, there will be individual interviews. We'll have interviews of 20 minutes. A bit more information about that on the next slide. But that is the examination. Once you pass that, you will get a grade. And yes, these will take place the 18th and 19th, and there will be enough slots for everybody. So you don't have to worry about being late or something like that. There will be times for you to sign up, and this will be announced sometime in December. So you will have time until then to prepare. Oral interviews, 20-minute interviews. I'm checking your comprehensiveness. And this comprehensiveness is usually achieved by experimenting with the code, with the assignments, but also reading the theoretical parts. And the learning objects themselves are a good preparation for you to know what to learn. So make sure to read the briefings carefully. So if you actively participate in Riva and you solve the assignments, then there shouldn't be any problem for you to get past. Procedure is that there will be slots. Sorry, here the dates here are wrong. I don't know why I put the wrong dates here, but it's the dates on the former slide that are the valid dates. There are sufficiently many slides. You sign up for the slides. That will happen in December sometime, and then there will be a virtual meeting via Adobe Connect. And you will have to submit your ID, and you have to have a functioning webcam and a microphone, and that's just the general yada yada. And you can also read that in the overview document. Yes, and if you don't show up, that's a fail. So if you sign up for the exam and you don't show up, that's a fail. As for any regular examination, if you don't go to that. So in this lecture, we're talking about the very start of the framing of the topic through the course book introduction chapter and the chapter 1. As well as the Java EE7 tutorial chapter 1. This is rather light reading with a bit of historical background and general pointers to why we do things different in Java Enterprise than we do in Java Standard Edition. Start talking about architecture, enterprise architecture, and giving it a bit more of a definition than I did in the formal presentation here. Talk about the first, that we will actually talk a lot about patterns, but here we're starting out with a very general pattern that you all usually use, and that's probably one of your, that's not really in everybody's active vocabulary, but that we should actually pull in that vocabulary to use it more frequently, and that is layering. And then we talk about Java Enterprise, more concrete. What is the difference to Java SE? What defines Java Enterprise? A bit more meat, more details than I gave before, and how do we structure a project? Yes, architecture. In general terms, architecture means that we break down a system in components, in different parts. And for us, especially as software developers, it's important to look at the interaction between the different components. How do they depend on one another? What is intrinsic with architecture is that it's hard to change. It's not easy to change a building once it's constructed. With software, we are lucky. We can actually make changes. It's still not easy to change, but it's possible. So that's something that we have to consider when we build our systems. We want to try to make them easier to change. And enterprise architecture then, as a definition, we could say that how do we compose an application into layers and how these layers work together. So layering is a really important concept here. And they don't have to be large enterprise applications. I mentioned earlier the old school approach of monolithic applications that are huge. These days, we oftentimes have very specific services that or applications that do a certain thing, and they do that thing well. So that's why enterprise applications don't have to be large, but they have to have the capability to scale into becoming large. So they could actually, in case that demands are raising, that those demands that we've been seeing in the former slides, we have many users, we have a large workload, etc. If these go up, then the enterprise application is able to cope with them. That's basically what the enterprise application makes it special compared to other applications that just run on a single system, say. So talking about patterns, we'll mention and introduce a lot of patterns, and some of them you will have to be able to refrain and discuss pros and cons in the examination. So here is a general definition of what a pattern is, and we can go back to some renowned person in the building sector, a building architect, Christopher Alexander, and he puts it like this, and I think this is very relevant even for us as software developers. Each pattern describes a problem which occurs over and over again, and it then describes the core of the solution too, so that in such a way so that we can use this solution in 1,000,000 times without ever doing it the same way twice. So patterns are interesting because they are not like a plan that tells us this is just the way to do it and you execute it and it's done. To start with, we have a problem that is of some general character, and so we abstract it in a way. And this is a problem that we oftentimes meet. So we, of course, want to have a solution to it. So we also describe an approach to a solution. But since we're working with systems that can be so different, we have so many potential situations where this pattern can come in handy, but they are not the same. So we will usually always have to adjust our pattern slightly to the situation. That is the challenge of using patterns. And it's as valid in the building sector as it seems, at least, as in the software sector. So this is a very generic saying about patterns. So some of the features of patterns is that they're based on experience. This is nothing that we just come up with for the future, knowing that we can solve things by a certain means generically. No, we learn that we have seen these situations and they make us believe that this is a good way to go. We also oftentimes talk also about best practices, etc. And there are usually good situations for patterns to use them. And something that I want you to be thinking of when whenever you choose a pattern in this course, then and in reality, of course, thereafter, is that you already when you see the problem itself, make up your mind of the different alternative patterns and the pros and cons, because that's always what you would have to do. There is usually not the perfect pattern for a problem, but you will have multiple patterns, and that all depends on the context in which you develop the application, which pattern is best for your case. And you will have to be able to justify that to your colleagues, to your superior, in order for it to be developed that way, and also for it to be future-proof. So this course is much about patterns and within the enterprise sector. But bear in mind that if we don't have the vocabulary to talk about these patterns, we cannot communicate them to one another, and we have difficulties in discussing pros and cons about this. So we build in this course, we build the basics of a way to communicate efficiently within our teams, which is very important in an engineering science or engineering field, such as the one that we're living in, which is still developing, and it's developing very fast. But many of these patterns stay the same and are valuable still today as they were 15 years ago. When it comes to the things that we haven't been that we de-emphasize in the course when it comes to scalability and fast responses and throughput, etc., these things that we can measure and that we can improve by experimental means, we oftentimes make a trade-off there. We choose a certain implementation because it's faster, whatever faster means. It's solving the problem more efficient in some way, but that usually comes with a price. Might not be as easy to understand. The algorithm could be quite complex. So one approach to address this kind of hoax when you meet this kind of problems is what I would recommend, and that is that you first try to solve the problem so that it's actually solved, even if it's been solved slowly, but it's easy to understand by other engineers. So you use a solution that is easy to understand. And here we talk about performance versus understandability. So once you have the understanding of the problem and an easy solution that can be understood, we can talk about how to make this faster. In most cases, this is a meaningful approach, because oftentimes we talk about efficiency and we talk about that it has to be faster, but we don't have really numbers about what is fast, what is good enough. But that is what we have to focus on. What is good enough? So when creating these systems, create them so that they can be understood. It might be that they're good enough. If they're not good enough, ask your superior what's good enough. So they have to give you concrete numbers which you can relate to, because otherwise you can always make it faster without really knowing the boundaries and with spending incredible amount of time for what you're doing without really getting a reward for that. So code performance optimization, it's not really part of the course, but just one thing, make it understandable to start with. Then when it comes to enterprise applications, they can be very diverse. There is not, as I mentioned already, they can be small, they can be big, but they should be prepared for all these different situations with concurrent users and transactional management and persistent data and large loads. But for example, just to give you an outline of examples, the business logic that is that can be required for these services can be small, like in an online shop. In an online shop, you don't have many advanced services actually that do extreme complex calculations. The main business objective is to sell goods, and there you just define the goods and you present them in some nice way, an easy to understand way, etc. And then that's basically it. You will have to have some payment engine, etc. That of course you can put on top of that. You can have analysis of your customers, etc. But that's not core of the application. The core of the application is the business logic that's trying to make the transaction real. So that can be quite small. Whereas if you look at leasing agreement services, they can be huge and complex, and you will have large masks of different values to be entered, and numbers and references, etc. And the business logic can easily be very, very complex. Whereas the user interface can be very small. It could be just one page with different input fields, but what's happening behind the scenes is what is actually the big challenge of this enterprise application. And online betting services probably cut somewhere in the middle there, that you have a business logic that's trying to analyze a lot of things, doing that live, etc. Might even spend bigger than the leasing agreement in some situations if you consider live betting, etc. But that usually offer a huge user interface with options to bet all kinds of things and all kinds of sports and events, etc. Making it tempting for you to bet on many things at the same time, etc. So enterprise applications can be very diverse. The pattern that we'll talk about first is the layering pattern, which is something that we naturally understand quite well. We try to separate a task into different subtasks in order to make it feasible to do the things that each So we have a task and we try to separate into subtasks, and each subtask is solved by somebody who's an expert in that field. So that's usually a very common approach. Like you have a boss who's making decisions, you have an architect who's making architecture, and you have a builder who's implementing the whatever the architect is telling the builder. So you will have a layered architecture. And what you want is you want to hide complexity of lower layers from the upper layers, and basically generally hide complexity from the layers in between one another. And that is in order for us not to be required to learn everything. So a builder doesn't have to handle all the process of the decision making and the architecture and the building. And this makes us more vulnerable because we are just an expert in this one thing. But in terms of software, this is a positive thing, because then we can focus on actually one thing at a time. One of the drawbacks of layering a system to a higher and higher extent is obviously that there is a performance leakage, because whenever the boss has to communicate something to the builder, it usually goes to the architect and then to the builder. So we have 2 steps, and we have a latency in between there. It might be that the boss cannot reach the architect by telephone, and so you have to wait, and the architect gets back at the boss, and then the architect tries to call the builder, etc. And this can create some performance deficiencies. But that is what we ought to make a decision about. If we're structuring things in software, what can we live with in the long run? And usually, to start with, is more important for us to have a good structure in order to be able to build large systems that actually can handle all these cases that we foresee in the future. Whereas the performance is something that we can optimize in the future. And here we also talk about the difference between logical and physical layers. This is more of a logical separation when it comes to the 3-tier model that I talked about, the user interfaces, the domain logic, and the data sources. Whereas here we include a physical separation, where we have the boss being a physical person actually, and the architect being another physical person. You can't deploy these people on a server or something. But in software, we have this differentiation, which is meaningful to us, because then we can discuss how we actually can separate or distribute the workload, the logical from the logical architecture to the physical architecture. So we have we reduce the complexity once again there by first focusing on the logical layer and then going into detail about the physical. Just a very brief outline of how we historically developed our systems and software systems. So before the 1990s, we would usually have server halls where everything is executed on at that specific place. So you wouldn't have the opportunity to be home and execute something that is on a server far away. And then somewhere in the 90s, or probably a bit earlier, we would have the opportunity to have terminals. I think Sun has been working a lot on that during that time, to have terminals that are pretty thin. You can't really execute much. They don't have they usually don't even have a a processor to execute things, they send everything over the wire to the server. And it's executed on the server and then sent back. But these terminals are usually then not far away. They're usually in the same building. But then the question is, if we have this separation of concerns, we have a client to the left and the server to the right, especially these days where we know that our clients are kind of real computers, right? They have processors, oftentimes multiple processors, and they have RAM, and they can basically do quite a substantial amount of number crunching. Where to put the domain logic? And the natural answer until now has been to put it on the server side together with a database, usually a relational database, because traditionally we didn't have the power, the processor power on the client. And now these days, what we do is usually that we place a lot of the domain logic on the server. We have another server that is the SQL, that is the relational database, or these days even other database like graph stores, etc. With this just being a conceptual, a logical view of things, right? We're not talking about how many SQL servers we actually have. We just say the SQL servers are somewhere else. And however many they are, they're hidden behind this abstract, logical SQL database symbol. So it gives us meaning to discuss these things here on a higher level, talking only about the logical aspects to start with. And so this is oftentimes what we do. We have the presentation layer on the client side, we have the domain logic on the server side, and we have extra on the back end. We often talk about back end. We have data sources on the back end that are relational databases or other kind of databases that are even detached from the server. And giving the tools of functional programming or object orientation, we get a nice differentiation of responsibilities here. So we kind of can spread things easily to their respective components. And in reality, of course, when it then comes to performance, we can make different choices. We can move some of the domain logic to the client, for instance, because we have offline applications and we want to make sure that the user can access certain things even when the internet is not available. Or we can move some of the domain logic to the databases, because it might be that there are some very computationally expensive procedures, and these procedures are best addressed if they are executed in the databases. But this is a good way for us to have an understandable system as a starting point, and then we can make decisions after that. Java Enterprise, as I mentioned, is a number of specifications, and we can actually read about those specifications on the Oracle pages. And they actually have an objective. They say out loud that they want to provide developers with a powerful set of APIs while shortening development time. So you should actually get services that simplify your life in order for you to be more productive. And this is developed by the Java community process, which is defined as an expert group or expert groups, because there are groups for different specifications. They have created Java specification requests to define the various Java EE technologies. So whenever there's some assessed need for a new way of a general problem that's been coming up, then this is discussed through the Java community process, and then these bodies, expert groups, they meet and they talk about how this can be addressed in a rather general way. They kind of try to find a pattern for the problems that are to be anticipated. One of the examples that's been discussed these days is how the containerization, the use of Docker and Rocket and etc. Can be integrated into Java Enterprise or other related standards for other development stacks, so to make the experience for the developer easier. Just as an example, that is highly discussed in the Java community process. And one of the what should be highlighted here is that much of the work that's been done with when you as a developer use Java Enterprise specifications is that you are configuring code. Instead of writing lots of code, boilerplate code, that you have to write again and again for many projects, you configure things in a way so that the Java Enterprise implementation understands, okay, so you have this kind of problem in front of you. So we can help you solving this in a generic way. And as I already mentioned, some of the examples of problems are transactional management, security handling, user control, for instance, and logging. So there are general routines for how you configure these everywhere appearing problems or situations. And you do that usually with XML. So you have XML files. This is, as I mentioned, in 2013 was the last time the standard was refined. In Java, they were putting a lot of stress on using XML. And an alternative to having external XML files is to use something called annotations within the classes, which you probably have seen before. You use them by writing an add, the add sign, and then you write the respective annotation. This is supported, I think, since Java 1.5, and you can create your own annotations to etc. Examples of annotations would be not null. You can define something as thread safe, etc. And it's not only, usually you do that before declaring fields or declaring methods and constructors, etc., or even classes. And this is parsed by the constructor, by the virtual machine when creating the bytecode. So actually, this has an impact on code, and you can use these hooks in order to do meaningful stuff. And that is used extensively in Java Enterprise, which you will learn and see during the course. Yes, but in principle, Java Enterprise is built on Java Standard Edition. So all the general libraries that are available under Java SE are available under Java EE. You can use them, and in our case here in the course, we'll use Maven in order to simplify this dependency management. So you don't have to download a lot of jar files to your computer and try to find them somewhere. You can just refer to them in your Maven POM file, where you just say, I need this library, and it will automatically download the library if you use the right dependency descriptor. But more about that later. What is very different between Java Enterprise and Java Standard Edition is the way that we initialize our services and our classes. Whereas in Java Standard Edition, we use the new constructor very often, where we create new objects. In Java Enterprise, since this is a server environment and new is usually an expensive operation, there are means for us to outsource this to the server. The server wants to have control about the management of the creation of expensive activities. And the creation of new objects and thread handling are two of them. And that's why we cannot just start threads the way we wish in a Java Enterprise environment. And we cannot just create objects. We can actually create objects the way that we want to, but we cannot expect that they are initialized by the server. In order for the server to help us and for us to use all the meaningful services that I mentioned for transaction management and security and so, we will have to follow a contract. And that is usually that we are injecting our objects. We instantiate it by, for instance, here, if you look at the Java EE annotation here, we have some annotation that is injecting something. This is telling the Java Enterprise platform that, well, okay, in this case, this is just an example. It doesn't exist, but it could be called inject. Inject is one valid annotation. So it could mean that the container, it's called the container, which is running the, which is implementing the specification. For instance, the standard implementation of Java Enterprise is the Glassfish server. So in Glassfish, we could say inject, and then it would inject the service, understanding that, okay, you're searching for the implementation of this interface, and you have somewhere declared that a certain class should be injected. So we have to follow this kind of contract. That's what we do. We follow a lot of contracts instead of just coding away however we wish like. And that is also to make it easier for others to maintain the software. And here we see the, this is again the general structure, the 3-tier architecture. And we see that there is a domain logic in between the front end and the back end. And that is usually what we consider being the Java Enterprise environment. That's usually the server, as we've seen before on the picture of physical architecture, that is offering us a certain number of services, and that we want to use these services. And the user interface is a totally different story. There are Java Enterprise standards for the user interface, and there are Java Enterprise standards for connecting to the backend. But the biggest emphasis is on the development of the domain logic. And here we see a bit more details about how this looks. This general architecture looks in the Java EE application. On the client machine, we have usually web pages that can be represented by JSPs, or usually we have HTML as a static content, and then we have servlets and JSPs, which are the standard for client-side or for server-side web applications, which you see here: Java server faces and Java server pages on the web tier. Below that, we have the business layer, which is a special layer with the so-called enterprise beans. These represent our services. And furthest down, we have the database layer, the database server. And in our business tier, which it is called here, we define the coupling between our enterprise domain logic and the relational databases. And that is what we will talk about in the first lecture in, I think it was 1 week, when it comes to Learning Object 1, how we actually connect the relational model to the object-oriented world. And we can do that by hand, but there are tools that help us simplifying this mismatch, because relational models are very different from object-oriented models, as you probably already know, but which we will go more into detail about next week. And something to take away is the EE reusable components may not work outside EE environments. That's what I mean with it forces us to follow the contract. So if you create an enterprise bean, you can actually create and instantiate it by the new operator, but you cannot expect it to run according to the contract, because then you're breaking the contract by creating an instance by yourself. So they are only reusable in the sense that you have to fulfill all the requirements for it to be reusable, and that means you have to run them in a container, in a server environment. What we see here is just the different means of separating the client from the server through. Actually, this is just a more client-oriented view on the communication, where we I mean, usually what do we do on the client side? We have applications through apps in app stores in our mobiles, and we have web browsers. We don't use applets anymore. We have usually these two types. Then we can have proprietary client implementations. For instance, as I mentioned earlier, the RMI standard, which allows us to do distributed computing without using the HTTP format. But usually these days we use the HTTP format to realize the server communication. even for applications, we then usually use REST services in order to access the access the server from the apps. And yes, as already mentioned, we have the Java Bean components, and they are optional, but they add a number of valuable features. And we have the web page components that directly allow for simple creation of web pages with dynamic content. And further down, we have, as I already showed, the Java persistence entities. Yeah, and as I mentioned, the different services that we get for free if we're using the Java Enterprise standard, and we also talk about, or we call this cross-cutting container services or cross-cutting concerns, if that is something that everybody has to deal with and that can be solved in a more generic way. And well, I mentioned these already: the transactional management, security. Interceptors is also one of these things where you want an easy way for existing methods to be intercepted by other calls, for instance, in order to not have to do your logging within your code. You don't want to have a cluttered code. So you can use interceptors in order to make sure that each time a method is called, a certain other interceptor method is called, and that one could actually do something actively, but the recommendation is not to interfere with the workflow, but only to do something externally. And that externally could be to log information. And yeah, it's optional to use an enterprise EJB container. Many stacks, like the Spring Stack, for instance, and I think even Struts, is not having it has some components like that, but it's not really centralized around having a transactional and security-aware boundary for reusability of the domain logic. And we will go into detail about why this might be meaningful in some situations and why not in others. But we see here outlined there are three types of containers that we will talk a lot about, and one of them is the web container for the creation of both web services using REST and SOAP, but also for presentation in browsers. Then the EJB container that is solving the cross-cutting concerns, and the JPA container, which then is solving the mapping between the database and the domain logic. And this is just a general view of how a Java Enterprise project looks like. On the assembly root, you have a meta-inf folder, which contains information for the server to understand about the application, how it is structured, what are the expected components, does it have web pages, does it have static content, dynamic content. All these things are part of the meta-inf folder. What is the database, for instance? Where is the database? What is the IP of the database, etc. That all is defined in the meta-inf. Then in the web module, you will have the actual dynamic and static web pages. Then you have the application client module, which contains all your code. And resource adapters, we don't go into detail about that, but EJB modules, for instance, are where you have the different services that you're offering to either your own project or other projects that are deployed in the same server. Because that is one of the big differences, right? We have servers that are running multiple applications at the same time, or can run multiple applications at the same time. So they can help each other. They can offer services to one another on different levels of abstraction, different layers. And the EJBs are usually what are the reusable components between those applications. Now, Java EE, there is a lot of numbers. And now, as I mentioned, current version is 7. Priority in the course is to understand the system as is. We know that companies migrate slowly. Large companies use older versions of the standard. So it's not uncommon that you will meet companies that you will work with companies that only support Java EE 5 or 6, and that obviously has consequences for you as a developer, because then you can't use the newest features. And that means for us here in the course that I will try to give you information and knowledge about not only the newest features, but also those features that are mostly used in reality. That is also one of the reasons why when it comes to web development, for instance, we'll talk a lot about JSPs and servlets, whereas there are other technologies that have taken over right now and that you would probably use if you build a completely new system. But if you come to an existing enterprise, or say to Skatteverket, you can be quite certain that they use still rather old technology with respect to the web frontend, at least when it comes to Java. So then what you will have to do is to learn these things the hard way, because they are on a more low level. We start there. We start on the lower level and try to understand things from the bottom up. But the main concepts are in principle the same. So if you understand them on the lower level, you will understand them on the higher level. Obviously, it's just easier for you to use them. Yeah. So and Java EE 8 is supposed to be released at the end of this year. I don't know the latest update actually, but I think it was postponed now from the September to November. I think that's what I remember. Yes, and one important thing, I think I'll put that up on the course board, is that Java EE 8 has until now Java EE has been owned by Oracle, and the whole process, and before by Sun. What is interesting is that they're in the process of making this whole Java EE development cycle open source, like the Eclipse process, for instance, and other processes. They're considering to make this completely open source, which probably has implications on how fast things are moving forward. Because now, since 2013, it's 4 years. It's a long time since. So that could actually have, and people would have a higher impact, because these expert groups are not as restricted probably to certain users, but probably more open. So this is probably, it's to be seen by many developers as a good thing, and advocates of Java as a good thing. So I believe this is probably a good movement, but more about that in the near future. This is a page of things that we will not focus too badly on. Just as an example, the Java message service is something that we will take up in theory. So you will have an understanding when it's good to use it, but we don't have any assignments based on that. But you will know once you're in a company and you have to solve a problem, okay, this is where I would use Java message service, and then you learn about it. Another thing is advanced security concepts. Using role-based management is something that we will consider in theory. Excuse me. But there won't be extensive lab assignments about that. Other APIs are pretty easy to understand, I believe. Java Mail, for instance. Sorry, my voice giving up on me. Java Mail is something pretty simple. So we're trying to focus on the core of what is assessed to be of most relevance for you when you start a new job as a beginner, as a junior developer somewhere. Now we've got some slides that I will cover in the next lecture, so I won't focus too badly on them. They are on synchronous versus asynchronous communication, which is important concepts for us to understand in the later run. Enterprise service bus, how that is relevant, and service-oriented architectures. But these are things that we will talk about in more detail once you read about the basics and got familiar with the working environment, which is also important for you, that you get into Bitbucket and that you get into River and you get comfortable with the communicating there, etc. So I think we can stay there for today. I think we covered a lot of grounds. I hope you have received some intro that it gives you a good justification for why this is relevant. And I'm looking forward to an interesting course with information exchange, and I hope this is not only an exchange between from me to you, but also from you to me. So I'm looking forward to learn a lot of stuff. Let's see. So with that said, I think I'll just ask you if you have any more questions, as it was stated in the slides, and if not, then I think we can call it a day. Any feedback about how this went? Do you think that was okay to use Hangouts, or did you experience any problems? Except for the delay, which is substantial. Okay, great. Then see you guys online in the Riven forum, and if I remember correctly, then the next lecture is next week, same time. Thanks for today. Bye-bye.